Hello, my name is Ellie Cyril Jr., and my science fair project is energy storage levels of different types of supercapacitors. This picture is a variable inside of my experiment, the double layer capacitor. All pictures were taken by me for future reference. The purpose of my experiment was to determine which type of supercapacitor could store and utilize the most energy in a short period of time. My hypothesis stated that if pseudocapacitors were used, then they would store the most energy because they store energy using the reduction oxidation reaction, which can be used to store high values of energy. The variables in my experiment included the independent variables, which were the types of supercapacitors, the constant variable, which was the lithium-ion battery, and the dependent variables, which were the amounts of energy each supercapacitor could store, represented by unfinished model cars. In my background research, I found out that supercapacitors are extremely similar to batteries. They both store and discharge energy. Unlike normal capacitors, though, they have higher capacitance abilities, but in turn, they have lower voltage limits, meaning they can take less amounts of charge at one time. Supercapacitors charge faster than batteries because they don't use chemicals, but use static electricity. Meanwhile, batteries are much cheaper than supercapacitors, which is why they still destroy them in the market. Usually when I refer to the market in my experiment, I am referring to the car industry, meaning what do we use to power our cars? While batteries are usually using dangerous chemicals, supercapacitors are safer and more predictable because they use static electricity. I also found out that there are three types of supercapacitors. There's a double layer capacitor, a pseudocapacitor, and a hybrid capacitor. They each have a right electrode and a left electrode, which are oppositely charged, meaning one of them is negative and one of them is positive. They have a separator and a liquid electrolyte. The double layer capacitor stores energy electrostatically using electrostatic electricity. Basically, the electrodes, once they become charged, will get attracted to each other and try to reach each other. But the separator blocks them, so they bounce off the separator, with each bounce exerting electrostatic force onto the separator. When this buildup of electrostatic force becomes too much, it is transferred to the liquid electrolyte, where it becomes electrostatic energy. Inside of the pseudocapacitor, as mentioned in my hypothesis, it stores energy electrolytically using the reduction oxidation reaction, or redox for short. Reduction is when an atom gains an electron and becomes more negative. Oxidation is when an atom loses an electron and becomes more positive. Reduction oxidation is when an atom loses or gains an electron while another atom gains or loses an electron. When voltage is applied, the atoms move back and forth between the electrode and the electrolyte, transferring electrons to the atoms inside of electrodes. This friction is what causes the electrolytic energy to be stored up and then can possibly be discharged. The hybrid capacitor combines both values of electrostatic and electrolytic charging techniques to store energy. This often results in them being larger and more expensive than their other supercapacitor counterparts. In my materials, I used one of each type of supercapacitor. I used an energy kit that had the things I needed for an unfinished model car, a stopwatch which was on my iPad. I had a AA battery holder, two AA batteries, a lithium-ion battery, and a roll of double-sided tape. In my procedures, I'm going to try to summarize as quickly as I can. I used all of the CDC guidelines, including washing my hands, disinfecting my area, wearing a mask, and social distancing during the experiment. After that, basically, I took out a car frame, a motor, and a wheel from my energy experimentation kit. Basically, I connect the motor to the car frame to give it the car design, and then I attach the wheel to the motor. Basically, when the motor is charged, it causes the wheel to spin. Then I attach the AA batteries to the AA battery holder, and the AA battery holder can now charge the motor. At the same time, I would connect the variable that I am testing to the motor at the same time. Basically, the AA batteries would now charge the supercapacitor and the motor at the same time. I would do this for 5 seconds, and then I would remove the AA batteries from the motor. Basically, now only the newly charged supercapacitor is charging the motor, and I can count how many seconds the motor is charged after removing the AA batteries to see after the supercapacitor is charged for 5 seconds, how long can it keep the motor spinning. After this, I will repeat this trial 9 more times with the same variable, and then I would switch to other variables. For my results and statistics, I used the average, the median, and the range. The average was to see the overall efficiency of each variable. The hybrid capacitor had the highest efficiency with the highest amount of averages. As you can see, the hybrid capacitor is the yellow on my graph, and it has the overall highest besides the pseudocapacitor. Meanwhile, the double layer capacitor had the lowest average and the lowest efficiency, as you can see here. I used the median just in case I had too many outliers and I wanted more specific results. Now, the median had literally almost the same exact results as the average, and the hybrid capacitor stayed the highest, and the double layer capacitor stayed the lowest, showing the outliers like this here, this here, this here, and this here were not problems. The range was used to see how safe the batteries and supercapacitors are actually inside of the environment. As I said, this is based off of car models, meaning that safety of cars is a big issue in the real world, so I am trying to test to see how safe these supercapacitors and batteries are. In conclusion, my original hypothesis was incorrect. I stated pseudocapacitors, if they are used, then they will store the most energy, but the hybrid capacitors actually stored more energy than the pseudocapacitors on average. My revised hypothesis would state, if hybrid capacitors are used, then they will store the most energy because they combine both electrostatic and electrolytic methods to store energy. Overall, the lowest out of the data was the double layer capacitor, the highest was the hybrid capacitor, and the least safe were the pseudocapacitors and lithium-ion batteries, with the most safe being the double layer capacitor. Some limitations were that the researchers' fingers may have touched the wires, possibly altering the amount of electricity conducted by them. Human error with the stopwatch, as inaccurate times may have been off by a few seconds due to human conceptions. And taking out the wires and putting them back in again may have caused delays between connections, possibly changing the amounts of time each of the variables were charged. And over time, the batteries applying voltage to the variables may have worn down, causing them to be less efficient in charging my variables. In conclusion, this is an extremely important asset to the world. This experiment is very useful because it shows that supercapacitors are potentially safer and easier to use replacement for batteries. Batteries have dangerous chemicals that can hurt the environment and humans. Meanwhile, supercapacitors are much safer in this sense. Also, batteries are much less prone to stay intact. They can blow up at any given moment and anyone can die. Meanwhile, supercapacitors are much less likely to do that. This experiment proves that supercapacitors can be invested in because they are not that far behind batteries inside of the market and can store more energy than lithium-ion batteries, which are the main types of batteries, in cars at least. In the future, more types of capacitors could be used than rather strictly supercapacitors. Large car engine supercapacitors could be used in order to replicate the driving of an actual car. Other sources of charge could be used rather than just AA batteries. And while being tested, you could take into account the relation of power to actual cost of the capacitor. For example, the hybrid capacitor costed the most and stored the most. If we had a cheaper hybrid capacitor, would we have different results? And different amounts of charging time could be used to observe if the batteries would perform better than the capacitors with more time. Basically, batteries have a curved discharge, meaning they use all of their energy over time, while supercapacitors actually end up keeping some with a linear discharge. So if they have more time to get more energy, would they surpass supercapacitors? And they could also be tested in different temperatures to see how temperatures actually affect the supercapacitors and batteries' actual ability to store and discharge energy. Again, my name is Ellie Cyril Jr., and my project is energy storage levels of different types of supercapacitors. Thank you.